Hello students, in this lecture we will study reflection and refraction of a light wave from a plane surface. Also we will study total internal reflection of light. When a light wave encounters a boundary which separates two media, then the wave is partly reflected into the first medium and partly transmitted into the second medium. So let us consider this is a boundary which separates two media. The first media which is air and the second media which is glass. So when the ray of light is incident, the wave of light, we will say firstly, the wave of light is incident onto this boundary, it will be partly reflected into the same medium air and it will be partly refracted into the second medium. For simplicity, we are drawing the waves in terms of rays here. Instead of drawing the complicated waves, we will show the light as a ray here. So this is reflection and this is transmission or refraction. जेव्हा लाईट इज इन्सिडेंट जेव्हा लाईट इन्सिडेंट आहे एका बाउंड्री वरती, जी बाउंड्री दोन मीडिया सेपरेट करते, तेव्हा लाईटचा काही पार्ट हा रिफ्लेक्ट होतो, काही पार्ट हा ट्रान्समिट होतो, त्यालाच आपण रिफ्रॅक्शन म्हणतो. सो what is a smooth and rough surface? See, this is a smooth surface. Why it is called a smooth? Because the irregularities which are there in this surface, they are very small as compared to the wavelength of incident light. The irregularities are there but they are negligible as compared to the incident wavelength. This is called as a smooth surface. When the surface is smooth, then what is going to happen? The angle of reflection is equal to angle of incidence. This is angle of incidence and this is angle of reflection. If the surface is a smooth surface, then angle I is equal to angle R. Such a reflection which is taking place at a smooth surface where angle of incidence is equal to angle of reflection, it is called as specular reflection. Polished metals, mirrors, liquid surfaces, etc. These are examples of smooth surfaces. So the reflection of light which is taking place at such a surfaces, it is a specular reflection. However, many surfaces have microscopic irregularities. In that case, what is going to happen? Reflection is actually the diffusion of light. The reflection takes place, but see here, because of these irregularities, the angle of reflection is not equal to angle of incidence. So, this rough surface reflects light waves at many angles, at different angles. That is why glare of light is not obtained when the light is reflected from such surfaces. For example, light which is reflected from the wall, wall has two small irregularities. But because of these irregularities, the light which is reflected from the wall will not give a glare, whereas the light which is specularly reflected from the water surface, it will cause the glare. जेव्हा लाईट भिंतीवरून रिफ्लेक्ट होते तेव्हा आपल्याला लाईटचा ग्लेअर नाही मिळत. त्याचं कारण वॉलमध्ये, भिंतीमध्ये बारीक अशा लहान अशा इरेग्युलरिटीज असतात, ज्याला आपण रफ सरफेस असं म्हणतो. परंतु जेव्हा लाईट एका स्मूथ सरफेस वरने रिफ्लेक्ट होते, त्यावेळेस मात्र लाईटचा ग्लेअर येतो. रिफ्लेक्ट झालेल्या लाईट पासून आपल्याला ग्लेअर ऑफ लाईट मिळतो. जेव्हा आपण फिजिक्स मध्ये रिफ्लेक्शन म्हणतो तेव्हा ऍक्च्युली आपण म्हणतो स्पेक्युलर रिफ्लेक्शन. इन फिजिक्स the term reflection is used for specular reflection. So this is a specular reflection which is taking place at the plane surface. Let us see laws of reflection. Specular reflection, as we have seen, the reflection which is taking place at a smooth surface, it obeys two laws which are known as laws of reflection. The incident ray, the reflected ray, and the normal to the surface, reflecting surface, all these three lie in the same plane. This is the incident ray, this is the reflected ray, this is the normal to the reflecting surface. All these three lie in a same plane. And the second law is the angle of reflection is equal to angle of incidence. To understand a refraction of light, let us consider this light ray AO, which is incident at the air glass boundary. Medium 1 is air, medium 2 is glass. The light ray AO is entering from air to glass. When the light ray enters from one transparent medium to the another transparent medium, it is bending at the boundary. See, the light is bending. It is not going straight, but it is bending when it enters the medium glass. This bending of light when it enters from one transparent medium to the another transparent medium, it is called as refraction of light. This is angle of refraction, the angle made by the refracted ray with the normal to the boundary. This is angle of refraction, this is angle of incidence. This angle of refraction depends upon the properties of these two media. Also, it will depend upon the angle of incidence I. The relation between angle of incidence and angle of refraction can be obtained in a simple manner. Sin I upon sin R is equal to V1 upon V2. V1 is the velocity of light in medium air, whereas V2 is the velocity of light in medium glass. So sin I upon sin R is equal to V1 upon V2. Now, we know that mu, the refractive index of the medium, is defined as velocity of light in vacuum, which is a constant, divided by velocity of light in the medium. So, this relation we can further write it as V1 is equal to C upon mu1, the refractive index of medium 1. V2 is equal to C upon mu2. Hence, it is equal to mu2 upon mu1, which is also called as mu21, the refractive index of the second medium with respect to the first. The refractive index of the second medium with respect to the first. So, sin I upon sin R is equal to mu21, the refractive index of the second medium with respect to the first. See, this is the relation which I have explained here. This is known as Snell's law of refraction. From this Snell's law, also we can see that if the angle of incidence increases, then the angle of refraction also will increase, because this ratio is a constant, mu to 1. So if angle of incidence I increases, angle of refraction R also increases. Further, for a given angle of incidence I, the angle of refraction depends upon the wavelength of incident light. Why? Because this velocity of light in the medium depends upon the wavelength. Velocity of light in a medium, it depends upon the wavelength of light in that medium. So that is why angle of refraction also depends upon the wavelength of the light, and it changes from wavelength to wavelength, means it changes from color to color. Now further we want to see when the refracted light will not be there. The complete light will be reflected only. That is total internal reflection. The medium which has a low refractive index is said to be an optically rarer medium. And the medium with a refractive index, higher refractive index, is called as optically denser medium. See here, the figure shows the light wave, the light ray, which is entering from water medium to air. Water is a denser medium. Air is a rarer medium. When the light is entering from the denser medium like water to the rarer medium, as shown in figure, to the air, then the light is bending away from the normal. This angle of refraction theta 2 is greater than angle of incidence theta 1. Now we know Snell's law of refraction. We have seen that Snell's law of refraction. What is Snell's law of refraction? Sin I upon sin R is equal to mu 2 upon mu 1. So here in this case, angle of incidence is theta 1, sin theta 1 upon sin theta 2. Angle of refraction is sin theta 2 is equal to mu 2 upon mu 1, or it also sin theta 2. We want to write this equation for sin theta 2 is equal to mu 1 upon mu 2 sin theta 1. Right? So this will be the expression for angle of refraction. Sin theta 2 will be equal to mu 1 upon mu 2 sin theta 1, which is shown here. Also, we know that mu 2 is less than mu 1, or mu 1 is greater than mu 2, because mu 1 is refractive index of water and mu 2 is refractive index of air. So water is denser than air, that is why mu 1 is greater than mu 2. See here, I have written this earlier expression again here. Sin theta 2 is equal to mu 1 upon mu 2 sin theta 1. This we have seen now. Also, we know that refractive index mu 1 of water is greater than refractive index of air, that is mu 1 is greater than mu 2. So this factor is greater than 1. What is the meaning of this? As theta 1 increases, theta 2 also increases. If theta 1 increases, then theta 2 also increases. So, when the angle of incidence theta 1 in the denser medium, if it is increased, then the angle of refraction theta 2 also increases. Theta 2 increases means what? The light is bending away and away from the normal. So, as we go on increasing this angle of incidence theta 1, what will happen? The refracted ray will bend away and away from the normal. and for some particular angle of incidence, the angle of refraction will be 90 degree. Theta 2 will be 90 degree. This angle of incidence for which the refraction angle becomes 90 degree. The light will graze along the boundary. The light will go along the boundary. This is called as critical angle. This is called as critical angle of incidence. So see here. This angle is critical angle. It is called as theta c. This angle of incidence for which the angle of refraction is 90 degree, the light grazes along the boundary. This is called as critical angle. If the angle of incidence is increased further, still we go on increasing the angle of incidence, then what will happen? There will be no refracted light. The light will be totally internally reflected. There will not be any refraction of light. So, if the light is incident at this medium, at the boundary of the medium which separates denser and a rarer medium, then and further if the angle of incidence is greater than this critical angle, then the light is totally internally reflected into the denser medium. There is no light which is refracted into the rarer medium as shown in the figure when angle of incidence is greater than critical angle. Thus, when the angle of incidence is less than critical angle, then the light is refracted into the rarer medium. If the angle of incidence is equal to critical angle as shown here, then the light will graze along the boundary of the two media. If the angle of incidence is greater than critical angle, then the light will be totally internally reflected into the denser medium. No refraction of light takes place into the rarer medium. This phenomena in which light is totally internally reflected from a denser to rarer medium, then from the denser to rarer medium boundary, then it is called as total internal reflection. Now, if we want an expression for the critical angle, it is very easy. We can easily obtain it. We know that sin theta 1 upon sin theta 2 is equal to mu 2 upon mu 1. When angle of incidence is critical angle, then angle of refraction is 90 degree. So sin theta c upon sin 90 is equal to mu 2 upon mu 1. Sin 90 is 1. So sin theta c is equal to mu 2 upon mu 1, which is obtained here. Sin theta c is equal to mu 2 upon mu 1. So theta c will be equal to sine inverse of mu 2 upon mu 1, right? But now if the rarer medium is air, mu 2 will be equal to 1. If rarer medium is air, second medium is air, then we can replace this mu 2 by 1. In that case, we will replace mu 1 by mu only, so that we will get sin theta c is equal to 1 upon mu. Here it is assumed that the second medium is air, the rarer medium is air. So in such a cases, sin theta c we can write it as 1 upon mu. Remember that total internal reflection will not take place when light will travel from the rarer to the denser medium. The total internal reflection takes place only when light travels from the denser to the rarer medium. Total internal will not take place when light is passing from the rarer medium to the denser medium. Now let us solve this numerical for the better understanding. Determine the critical angle of a light ray traveling from water to air. So this is water and this is air. So the second medium is air here. The light is moving from water to air. We want to find out the critical angle at which total internal reflection will take place. Now, as the rarer medium is air, we have seen that sine theta c is equal to 1 upon mu. So, sine theta c is equal to 1 upon 1.333. So, sine theta c is equal to 0.75. Check with your calculator, you will get critical angle to be equal to, it comes out to be equal to 48.61 degree. Hence, the critical angle for this pair of two media, water and air, it is 48.61 degree. Thank you, students.